Yes guys, we've got a question from the daily integral here. It looks quite tricky, but let's start. So we're integrating all of this from 0 to 1 with respect to x. First thing to notice is that we've got a lot of similar stuff within the brackets for arctan. For example, 1 minus x. Well, that's not anywhere else but x and x. And 1 minus x. This is somewhat similar. So what we can do is use a substitution. So we'll say let u equal, now if we say let u equals 1 minus x, x will just be 1 minus u. Therefore we'd have essentially the same denominator. So if we go ahead with this substitution, du over dx is just minus x, which means that dx equals minus, du over dx is minus 1, which means dx equals minus du. Now let's go ahead and make this substitution. So before we start, x squared minus x plus 1, let's quickly evaluate that on the side. Sub in 1 minus x, so 1 minus u, so we have 1 minus u squared minus 1 minus u plus 1, u squared minus 2u plus 1, minus 1 and plus 1 cancels, so we've just got plus u squared minus u plus 1. And the fun thing with that is that we've just got essentially what we had before, instead in terms of u rather than x. So I think that would be interesting and somewhat useful. Let's go. Oh yeah, and before we substitute everything else, we need to shift our bounds. So where we had 1 and 0, where x was 1, u will be 0. Where x is 0, u will be 1. So again, that's nice. So let's call this integral I equals 0 to 1, and e to the minus arctan u squared minus u plus 1 minus arctan tan minus 1 minus u. Then, well, our denominator will just be the same, except we have in terms of u, so x and 1 minus x. So e to the tan minus 1 u plus e to the tan minus 1. I should be saying arctan actually, not tan minus 1 minus u. Then the dx becomes minus du, so let's put the du there and the minus on the outside. Now since we've got a minus on the outside, well, we can simply just swap our bounds and remove the minus. Let's bring all that down. Now, well, if we've got I here, if we compare this to our original integral, our denominator is essentially the same, and if you look at the top, we've got the same bracket here, except here where we have x, we have 1 minus u. So I think it would be a good idea to just add them, simply just adding two i's. We have 2i equals the integral from 1 to u, so 1 to 0, and let's say x is now equal to 0. Say let x equal u, not u, let x, sorry, not x equals 0, x equals u. If we add them, well, our denominator is just the same, so e to the arctan u plus e to the arctan 1 minus u, e to the minus arctan u squared minus u plus 1 minus tan minus 1, 1 minus u. And now if you just add the original, e to the minus arctan x squared minus x plus 1 to e to the minus arctan u squared minus u plus 1 minus arctan u minus arctan u. Alright, if you have a look at this now, well, we've got a lot of repeating terms. For example, we've got e to the arctan u squared minus u plus 1 here and here, e to the minus tan arctan 1 minus u here and here, and e to the arctan u here and here. So what we can do, we can just start simply calling these complex looking terms something else. So let's start off with e to the arctan u squared minus u plus 1. So say let a equal e to the arctan u squared minus u plus 1. Next term, arctan 1 minus u. So let's call b, instead of calling, well, we've got a minus, so this term here is actually e to the minus arctan 1 minus u. So let's call b arctan, not minus arctan, just arctan 1 minus u. So this term here would just become a over b, because that minus means we can just write it as 1 over b. Cool. So we've done u squared minus u plus 1, 1 minus u, and e to the arctan minus 1, so e to the arctan u. That's our final substitution. So now we can say 2I equals integral from 1 to 0 a over b plus this here is a over c all over b plus c du. Now if we combine this fraction on the top, we now have ac plus ab all over bc. Respect to u, this means 2I equals 1 to 0. We have AC plus AB over BC times by 1 over B plus C. Now we're looking for some sort of cancellation here, and notice how this all just factorizes to A times B plus C. So what we can do is simply cancel, so we're left with 2I equals integral from 0 to 1 a over bc with respect to u. Now this is much easier now to deal with, so what we do is substitute a, b and c back in. So we said a was A was e to the minus arctan u squared minus u plus 1. And what we can do is, since there's a minus here, we can just bring this a term down to the denominator with the rest of the variables b and c. So we say e to the arctan u squared minus u plus 1, and we times it by b and c, which have arctan 1 minus u and arctan u. So that becomes plus tan minus 1 u plus tan minus 1 1 minus u that's right. Now we've got all of this, let's look for some sort of simplification here. Well, notice how we can add these two terms and look for something nice. So we can use the identity tan arctan of A plus arctan of B equals tan minus 1 A plus B over 1 minus AB. So if you do this here, we're left with 2i equals 1 0 1 over e to the tan minus 1 u squared minus u plus 1 plus, so in this case here, the a plus b becomes 1 minus u plus u, which is 1, over 1 minus ab. So that's 1 minus u times 1 minus u, 1 minus u plus u squared. So that is now u squared minus u plus 1 so now we've got arctan times something, so arctan of something plus arctan of 1 over this something. So let's call this something, I don't know, let's call it A. And we know there's a very useful identity that we can use here, so I'm going to start off by proving it. So let's say theta equals arctan of, let's say, I don't know, A. Now tan theta equals A, and we know tan theta to be sine theta over cos theta. It's A. Now if we just flip both sides, we have cos theta over sine theta equals 1 over A. And to further simplify this, we need to use the fact that cos theta equals sine pi over 2 minus theta. Conversely, sine theta equals cos pi over 2 minus theta. So we have sine is equals sine pi over 2 minus theta over cos pi over 2 minus theta, which equals 1 over a. Now, the left hand side can just simplify to tan pi over 2 minus theta equals 1 over a. And from here, we can take arctan of both sides. So this should be an implies. So if you take arctan of both sides, we have pi over 2 minus theta equals arctan 1 over a. And we know theta here to be, if we go back up, theta was just arctan of a. So pi over 2 minus arctan of a equals arctan 1 over a. Therefore, arctan of a plus arctan 1 over a equals pi over 2. Now if we go back up to our integral, let's add du here firstly. Let's copy this down. There we go. So this identity says that arctan of a plus arctan of 1 over a equals pi over 2. So that just means our exponent of e just becomes pi over 2, which makes this question very easy now to integrate. So if we integrate 2i, we have u over e to the pi over 2. We just bring a u in because e to the power of 1 over e to the power of 2 is a constant. Integrate from 1 to 0. So 2i equals 1 over e to the power over 2 minus 0 over e to the power of 2, but we can just get rid of that. Therefore, I equals 1 over 2 e to the pi over 2. Finito. And that's it. We used a couple nice identities and we got a really clean result, so I'm happy with that. That's all for today. Should be back with a few more integrals now.